All right, good morning. So today's topic is rolling without slipping. See, in rotational motion, this is the most important topic for NEET and JEE mains and all the boards. The specific nature of this motion is that you have both translational motion and rotational motion involved in this. So there are two velocities, which are involved. One is the velocity of center of mass. The other is the velocity which arises because of rotation, which is r omega. So the point which is in touch with the plane, for example, it's a tire, a car tire. The point which is in touch with the plane, if that point is at rest, we say it's a case of rolling without slipping, right? This is very important to understand that what is the difference between rolling with slipping and rolling without slipping. If you see some cars which are, trying to accelerate, the tire, rotates very fast, but the car is not moving very fast. And you can see a lot of dust getting, emanating from that place. A lot of dust, tire is rotating very fast, but the car is not moving with that level of speed. So the impression the rotation of tire gives you is of high speed, but you see a lot of dust. These are the cases of rolling with slipping. So we say the tire is slipping. The very important condition for the rolling without slipping is the condition of V is equal to R omega. You can easily apply this equation for rolling without slipping. So when you do numericals on rotational motion and you reach the topic of rolling, you have to learn rolling without slipping and rolling with slipping. I'm going to now show you a numerical which has some discussions on rolling without slipping. So just go through that, listen to it very carefully. It is very important for you to practice this topic immensely. So physics, you have to be in touch with every day. You can do some 5-10 questions a day. That should be enough. And as the exams are proceeding, it is important to practice and stay in touch with the subject. Otherwise, you tend to forget it or not grasp it properly. So watch my video on this topic, and thank you very much for your time. And I will come out with my next video very shortly. Thank you.
All right, so we were talking about rolling motion and especially the pure rolling. Now, in the case of pure rolling, the net velocity of the bottommost point is zero because the velocity due to the rotational motion with respect to axial is in opposite direction to the velocity due to the linear translation motion. So at the bottommost point, the vector of velocity due to rotational motion is opposing the vector due to linear motion, and therefore the bottommost point appears to be zero with respect to the surface. So you must understand pure rolling is made up of two types of motion, and we generally study pure rolling by dividing the motion into two parts, and then we take points on the rolling body and try and find out the resultant vector due to linear translation motion and rotational motion.